Hey, it's Piet again. Now, one thing missing on my CNC is spindle control, so currently I have to manually stop my spindle. Now, this mill does come with a plug down here that is for external control, and I believe it takes a 0 to 10 volt control signal. So I just want to verify that and then connect that up to my CNC controller, and then the computer will be able to switch the spindle on and off. Right, so let's just quickly see if we check what the pinouts are and see what we can get from looking inside here. Right, there goes one plug off, but I'm sure we'll figure out where it came off from. Looks like the DRO. You'll have a pluggy back there. Okay, so now can you guys see? Okay, so here's the control. Here we can see the back of that plug. If we take our mains switch out the way, we can see we got two wires there diagonally apart, and that'll be pin 1 and 3. Yeah, 1 and 3. So that is the signal. I think my next step is now to just solder a bit of cable onto the plug and then see, is it open short or is it a 0 to 10? Try with open short first, nothing to lose there, then put a power supply on and test 0 to 10. The other thing I want to do is on the e-stop to put another contact in, so that I can then use the unused pins there to send the e-stop to my controller. So that is probably a future step and not for right now. I don't think I have this particular model in stock. Right, so just a quick one. There is connector 3 back there that is currently empty, and it looks perfect for the little plug that's just come out. So I would say the DRO plug that popped out as I open this up goes in there, just for those who are worried about that. It will be reconnected. Okay, so I've connected the put a 4-core cable onto it, and my first step is just to check if we're getting any voltage on it. The mains power on. It's supposed to be an isolated input. I'm not yet sure if I can select how to select, whether it's automatic, whichever one first gives signal. So let's see. There is, don't know if you can even see the screen. So there I'm getting -11. Okay, so we've got green negative, yellow positive, and there is a definite 11 volt. So it looks like this is powered. Okay. So it's perfect for now, because it means I have a plain on off. It's exactly what I want for right now. There is a 3-head, let's give you a bit of a better angle there. There is a 3-way sensor built in here with which we can pick up index and 2 spindle pulses, so we can get speed and direction from it. I will in future be tying into that so that I can feed that into my Linux CNC. And yeah, I'll be changing this connector out and putting a multi-way cable in to integrate with the computer. But right now I just want start-stop control, and let's have a look at the computer itself. Okay, So this is the inside of my processor. If you haven't seen that yet, I've got the actual PC mainboard and everything back there. This used to be a VDR casing, as some of you would have noticed. If you know the marine field, it's basically the black box that records the voyage on ships. Here I've got my 3-stepper drivers. They don't need this big resistors, it's just that the surface mounts supplied by the original designer get too hot for my liking. And then here's the output board that I designed. I just need to finish placing parts on the input board, then I'll fit that one. But this is all we need for now. This is still temporary wiring because a lot of it is going to the other card once I finish that. This is a optically isolated parallel port interface that I have designed and built. And pin 14 is currently allocated to spindle on off. So I need to see how I can best bring this onto pin 14. Now if it's an isolated supply, I should be able to ground the green and put the positive straight onto pin 14, because these are common emitter or open emitter, emitter follower, can't remember the right wording, pull to ground. The outputs will pull to ground and it should be very low current, so I don't think the little transistors that I've got would be a problem. So let's see, what is my 0.2 volts to ground. That's very good, very promising. And minus 100 millivolts to ground. So it should be perfectly safe to ground this. Let's just switch them all on and do all of those tests again. So we've got the spindle run stop on that or on that. We can control either way. And interesting question. Okay, so the stop button always works, the start only works on that one. Let's just retest that with the power on, just in case. Obviously the circuits wouldn't have been powered. No, 0.3 and 0.1, so it is isolated. If we ground that, no sparks. Very good. So let's put this into pin 14. It looks like 14 right there. And if I run that, okay, so I'm getting current through there, but that's normal. It'll be a bit of reverse voltage, I think. So let's see. In testing, can I test spindle on or off? No, I can't. Okay, cool. Yeah, let's just launch that. Power the machine. And can I do... yes I can. So, right, spindle start stop does not work. What's my circuit? So I've got, you can see, can you see? I hope you can. Yeah, you can see. That's running spindle start and spindle forward, and then if I run the spindle in reverse, it's running only spindle start. So on this system, spindle run, and then pin 15 would then be for spindle forward. If 15 is not active, it's spindle reverse. So that's an easy part. Now let's just see what we can do there, and if I need to invert polarities. I just want to double check before I go there. Okay, so I found the problem. Truth is, this will actually pull up, not pull down. So if I go between ground and pin 14, then when I switch my spindle on, I'm getting 5 volt coming out. So that's not a problem. We have a solid state relay. and we will simply fit this into the circuit. It can handle 7 amps, so it should be fine. You can take a 5-volt control. Right, so let's see. Let me know in the comments if you guys prefer to see all the connections or not. Run stop, and this thing, I don't think those are actually LEDs. So I tend to pause when I'm connecting things because it can be tedious, but maybe some of you like it. Right, so just bring the one on for now. Right now it's open, so there's nothing happening. And if I switch my spindle on, voila, it works. Cool. So that means that my negative on there. Someday I'll come back and clean all of this up and neat and tidy and all of that. But right now, I'll just run this. No, that's going too skew. Out. There we go. That on there, and we now have spindle control. So let's home the machine and see how we run with everything. Right, so you might remember the paper holder covers that we've been cutting the other day. Now we're going to cut this again as a test with hopefully automatic spindle control. There we go. Start the vacuum. Whoa! No, that's definitely not right. I know what happened. I never loaded the file. Paper holders. There we go, that's looking better. I think we're a bit low. We're cutting a little bit deep at this stage. But that's just one. I'll check it just now. Perfect. Exactly what I was hoping for. Right. It's today's first little chore done.